Welcome to Para University. Today we're going to be talking about hexadecimal. Looking on the left side of the screen here, I have a table up here with all the values of hexadecimal, which just kind of break down the word hexadecimal. It means it's going to have 16 possible values. So in the column on hex here, you have 0 all the way down to F. And in the middle, we have the decimal representation, or more what we're familiar with. You can see 0 through 9, no change. That's what we're familiar with. But then we get to A, B, C, D, E, F. So A is going to be the equivalent to saying 10, B is 11, C is 12, D is 13, E 14, and F is 15. So if you have hexadecimal of just F, that's like saying 15 in regular decimal. And then on the right, we have binary values that are the equivalent, all the way from 0, 0, 0, 0, which of course is 0, all the way down to 1, 1, 1, 1, which is 15. Something I want to point out real quick that's really important. This is always 4-bit binary. There should be 4 digits. If you have more or less than 4 digits when you're converting hexadecimal with binary, you're doing something wrong. Go ahead and stop, reevaluate what you're doing, and think it through, because you're going wrong somewhere. All right, before we kind of get into a couple of examples, let's take a look at what we have here in front of us. All of these are actually hexadecimal values. And so this is not 48, this is 48. That's not 65, it's 65, 6C, 6C, 6F. And those of you familiar with ASCII values and hexadecimal will know that this actually says something we're all pretty familiar with in the programming world, which is hello world. Kind of always everybody's introduction to a programming language, hello world. I thought I would just do hello world in hexadecimal. So this is going to be capital H for 48, and then lowercase e, l, l, o, capital W, lowercase o, r, l, d. All right, let's talk about hexadecimal for a little bit, and then we'll come back and convert some of those into decimal form, kind of as some worked examples. So let's scroll down a little bit. I have that same chart on the left side just to keep handy as a reference. So hexadecimal is base 16. So when you're converting, particularly from hexadecimal to regular decimal, always remember your base is 16. There's 16 possible values, 0 through F, that each column can have. And remember how columns go, so let's not worry about values in them, but this is column 0, column 1, column 2, column 3, because we always start counting from 0. And this would be 16 because it's your base to the power of 0, 16 to the power of 1, 16 to the power of 2, or 16 squared. And lastly, that would be 16 cubed, and of course I can go to the 4th, 5th, 6th, however many columns you want. So we know we're base 16, so how many possibilities and what's the range of a hexadecimal number? So the number of possibilities is base 16 to n. N equals the number of columns. So let's say we have 1AF. We're not going to worry about the value of 1AF, but let's talk about, because it's a 3-digit value in hexadecimal, how big its range could possibly be. So we're going to have 3 columns, right? So 16 cubed is going to be the number of possibilities, minus 1 will equal the range. 16 cubed, I believe, is 4096. And you got to subtract 1 to get the range. So 4095 equals the range of a 3-digit hexadecimal number. And luckily, if you're doing hexadecimal, you should already be pretty familiar with binary and how to convert binary and decimal back and forth, which should give you a pretty good leg up on converting hexadecimal. But first, let's go ahead and take a hexadecimal number. So let's go ahead and use 6C. So the first thing we want to do is identify this as hexadecimal. So we know it's going to be base 16. And just something I kind of wanted to point out, writing 6C with the parentheses and base 16 on the outside is the exact same as writing 0x 6C. That's a common hexadecimal notation, something you're going to see regularly, especially in more computer engineering and programming classes. Just kind of as a heads up, and know that those are identical statements. So first, let's count the columns here. This is column number 0, because we always start counting at 0, and this is column number 1. Remember, those are going to be the exponents of your base 16. So let's go ahead and start on the left. So we have the number 6 times base 16 to the power of 1, parentheses, plus c, but c is obviously not a number. It's going to work for multiplication. So let's look over our table and find c. And c is 12. So 12 times base 16 to the power of column 0, so power of 0. And then I think we kind of all see how we're going to simplify this. 6 times 16 to the power of 1 is 6 times 16, plus 12 times 16 to the power of 0 is just 12 times 1. 6 times 16 is 96, plus 12 is going to be 108 in decimal or base 10. Again, if you go look at an ASCII table, you'll see that lowercase l is given number 108, and the way that a computer will see that in hexadecimal is with 0x6c, or 6c base 16. Okay, now let's do an example where we take a decimal number and convert it to hexadecimal. So let's use kind of two different methods here. Method number 1, we're going to first take our decimal number, which we're going to use 280, because why not? And that's going to be base 10. And the first thing that we're going to do for method number 1 is we're actually going to convert this to binary, and then with binary, it's really easy to convert to hexadecimal. So what we're going to do is, remember, write down 280 minus our largest power of 2, which is less than or equal to 280, which is going to be 256, which is 2 to the 8th. 280 minus 256, that is going to be 24. And we really need to remember 256. That's going to be one of our binary values. So 24 minus the next biggest power of 2, which is less than or equal to 24, is 16. That equals 8. And then 8 minus 8, since 8 is less than or equal to 8, and it's a power of 2, we have 0. So we have 3 essentially on values, or values that will be identified as a 1 in binary. So we have 256, but we don't have 128. We don't have a 64. We don't have a 32, but we do have a 16, an 8, but no 4, 2, or 1. All right, this leaves you with 1, 0, 0, 0, 1, 1, 0, 0. Fill out these zeros a little bit better here. Now, what we can do, let's go ahead and just move this up to here. 1, 0, 0, 0, 1, 1, 0, 0, 0. Now remember, we're going to split this into 4 bits at a time. So bit 1, 2, 3, 4, draw a line. 1, 2, 3, 4, draw a line. And now we just go reference our chart, and we're going to fill in each hexadecimal value equivalent to the binary values that we created here. These are three separate binary values is how you look at this. So 1, 0, 0, 0, that is the equivalent to 8, and 8 is going to be just 8. So that's your first hexadecimal value. 0, 0, 0, 1 is just 1. That's just going to be 1. And then again, we have 1 over here with leading zeros, so another 1. So we have 0, x, 1, 1, 8, or you can write that as 1, 1, 8, base 16. Those are going to be the same values. So now let's try converting 280 to hexadecimal with method number 2, which is basically the exact same as when we converted a decimal number into binary. What you're going to do is start with your 280, and now you kind of have to think, what are your powers of 16? So again, this is why I think it's a little bit more difficult, because that's a lot to remember. But 256 is your largest power of 16, less than or equal to 280. 280 minus 256 is going to be 24. We have to remember 256. And we have to remember that 256 goes into 280 only one time. So I'm going to write a little parenthesis and just one time. Write down 24 minus your next biggest power of 16 is 16. 16 to the power of 1 is just 16. That's going to be 8. And again, 16 goes into 24 only one time. 8 minus something is going to have to equal 0. Remember, 16 to the power of 0 equals 1. So 8 minus 8 equals 0. But how many times does this 1 go in there? It goes in there 8 times. And this is one of the reasons why I think it's confusing. You have to remember the number of times a given power of 16 can go into the number you're subtracting. So let's go ahead and write this into hexadecimal and kind of get a gist of what we're talking about here. So 256 is present one time. That's going to be column number 2. Column number 1 is for 16, because that's going to be 16 to the power of 1, being at 16 to column 1, which is just 16. It's present once. And now 16 to the 0 equals 1, but 1 is there 8 times, because 1 times 8 is 8. So there you go. 118 base 16, which is equal to 0x 118. That's the exact same thing. I'm going to have a different video with a couple more examples where we just kind of go through them, kind of drill these problems to kind of reinforce them, turn these into concrete, and that way on your test, hopefully you can knock these out, because I know this is always a bit confusing. It's definitely a little bit difficult for me, especially doing the hexadecimal conversions. But I hope you got something out of this. Hope you learned something. Feel free to ask questions in the comments. Thank you very much. I hope you have a great day.